Number 33, we have a word problem relating trigonometric functions. So we have, it says, suppose that an airplane is asked to stay in a holding pattern near an airport. The distance of the plane to the airport is described by the following. D of t equals 131 plus 75 sine of 2 pi over 9 t. In this equation, d of t is the distance of the plane to the airport in miles, and t is the time in minutes. After the plane enters the holding pattern, during the first 9 minutes after the plane enters the holding pattern, when will the plane be 170 miles from the airport? Now, here, the most important thing is that we acknowledge that we have d of t equals 170 miles. And what we're looking for is the time this happens. Time when this happens. It will happen once or twice. Now, something important about this, it says during the first 9 minutes, which means that our time is from time 0 to 9. Not including the 9, of course, because it says during the first. Now, where do we start? We start with this equation, and we say d of t is all this. So we have 131 plus 75 sine of 2 pi over 9 t, and that happens to be equal to 170. The goal is to solve this. So solve for t. So what we do is we try to isolate it. Let's isolate the sine function. So we have 75 sine of 2 pi over 9 t equals 170 minus 131. And then to isolate it completely, we need to divide by 75, because 170 minus 131 is 39, divided by 75. So it is not necessary to solve this fraction, because we can actually use a calculator for this. Now, remember, we have to work with the inside of the sign. It says that this equation says that we have two solutions. When the sign is positive, when does this happen? It happens when in quadrant 1, so we'll have this angle, and also in quadrant 2, because here the y, which is the sign, is the other angle. And the other angle can be found using it's pi minus theta. So the first thing we need to do is, let's change the variable. Let's change the variable. So if, I'm going to continue here. So if u equals 2 pi over 9t, then you say, okay, sine of u equals 39 over 75. And then you say, okay, so I'm going to need the angle of reference, which is always a positive. If this was negative, we had to use the positive, right? But here we don't have a problem because it's positive. So u happens to be the sine inverse of 39 over 75. That is our angle of reference. And with this, we will find the other solutions. Now, the solution 1 is easy. I'm going to mark one with blue and the other with red. So the first solution is when the angle is just the original reference angle. But remember remember, when we have to go back to t because we're looking for t. We're not looking for u. We're looking for t, for the time t. So we say, okay, so the angle 2 pi over 9t is equal to the reference angle because it's the same, right? So sine inverse of 39 over 75. So to isolate t, the first, let's say t1 time 1, you say sine inverse of 39 over 75. And then the 9 goes multiplying and the 2 pi divides it. So t1 is equal to, let us use a calculator. So t1 is 0.78 minutes. Now, let us find the second solution. Now, the second solution, we have to also use the reference angle and subtract it to pi. But keep in mind that T2, let's use another color. Let's say black. So the T2, 2 pi over 9, T2 equals, now here pi minus the reference angle, sine inverse of 39.75. So what do we do here? Well, T2 will be 9 times pi minus sine inverse of 39 divided by 75. All of it divided by 2 pi. Okay, again, we use our calculator to check and we get. And T2 will be 3.72 minutes. So we are done. The time 1 and time 2 are inside this interval. So we can say that we are correct. Thank you.